Okay, today I'm going to cover the midpoint theorem. What is the midpoint theorem? It's something that you've never seen before. So basically it is this. There are two lines here. Okay, if for the two lines, D is the midpoint of AB, E is the midpoint of AC, then by the midpoint theorem, DE and BC are parallel. And also if it's a midpoint, okay, D and E were the midpoints, DE will be half the length of BC. So this is a given. Or the reverse is true if you can prove that DE is parallel to BC and DE is half the length of BC, then D and E are the midpoints of AB and AC respectively. So that is the so that itself is the midpoint theorem. Let's see how I can use the midpoint theorem in some questions. So in example 3, well, we have a trapezium, okay, then E, F and G are the midpoints of lines AB, BD, okay, so F is the midpoint of BD and G is the midpoint of DC itself. So now, okay, what we want to do is to prove that EG is parallel to AD. Okay, now what we do is this. Okay, so what we will say in triangle ABD, okay, let me highlight the triangle for you. Okay, for this triangle itself, all right, you notice that you already know that E is the midpoint of AB and F is the midpoint of BD. So straight away, okay, I can say this, since E is the midpoint of AB and F is the midpoint of BD. So therefore, by midpoint theorem, okay, I can say that EF, okay, will become parallel. EF will, by midpoint theorem, EF is parallel to AD. Then since, okay, EFG all lie on the straight line, okay, so therefore EFG is a straight line. What we can say is that EG, okay, is parallel to AD. Okay, why parallel? Because EF is parallel to AD by midpoint, so therefore EG, since EFG is on a straight line, EG is parallel to AD itself. Okay, part 2. So part 2 is to prove that EG is half of AD plus BC. Okay, now what we have is this. I will consider two triangles here. So the first triangle is this. Okay, so for this triangle, I can say this, F is the midpoint of BD, G is the midpoint of CD. So if these two are the midpoints, so by midpoint theorem, what I can say is that FG is parallel to BC. That's one thing, okay. What I can also say is that FG is equals to half of BC. Similar idea, okay, now let me just erase all of this. So now the other triangle that we can find, okay, or we can use is ABD. So ABD was the one that we already used in part 1 itself, which is this triangle here. So for this triangle here, okay, I will say the same thing again. F is the midpoint of BD, okay, E is the midpoint of AB. So that means by midpoint theorem, you have to state that, okay, by midpoint theorem, okay, what we can say is that EF is equals to half of BC. Now, if I want to find EG, what is EG? So if you think about it, EG is made up of two parts, is EF plus FG. So I can say that EG is EF plus FG. Do I have EF and FG? Yes, I did. I have EF, I have FG here. So EG is equals to EF, which is half of BC, plus FG, half of BC. EG is equals to half of BC plus half of BC. Okay, I made some error here, didn't I? Okay, FG is half of BC. I think I made an error here. EF is actually half of okay, F is a midpoint of BD, then E is a midpoint of AB, so EF is half of AD. My error there. So what we have here is half of BC and half of AD. So I get is BC plus AD. Or if you write it the other way around, it's half of AD plus BC. So I have shown. Okay, if do pause the video and try 3 before I give you the answers to this. Okay, for try 3 itself, okay, if I want to find first I consider triangle CAB. So for triangle CAB is here. What I can actually say here is this. It's given that E is a midpoint of AC and F is a midpoint of BC. So E is a midpoint of AC, F is a midpoint of BC. So since they are both midpoints, by midpoint theorem, I can say that AB and EF are parallel. Similarly, if I erase all of this, okay, then I use the other triangle, the triangle BCD. What I actually have here is this. E is the midpoint of BD, F is the midpoint of BC. So by midpoint theorem, EF and CD are parallel. So AB is parallel to EF, EF is parallel to DC. So by logic, AB is parallel to DC. So AB is parallel to EF is parallel to CD. Now, next part is this. First, we consider triangle CAB. So if I consider triangle CAB, down here like this, okay, I know that by midpoint theorem, my EF is half of AB. So I write that down, okay, by midpoint theorem. Similarly, all right, if I just highlight the other triangle, okay, what I have is that EF is half of CD by midpoint theorem again. So now I have EF as the common side, so I can say that EF and EF can actually be so what I can say that is half of EF is equals to AB. Okay, so if I actually prove this, okay, so I can say that okay, give me a moment. So EF was actually half of AB. Okay, that one we wrote down. EF is actually half of CD. We actually wrote that down itself. So okay, we should not try to eliminate EF. Why? Because if I eliminate EF, that cannot prove that EF is 1/4 AB plus CD itself. So what I can say here is this. Okay, so what we can actually use to prove here is if EF is equals to half of AB and also EF is equals to half of CD. So if you think about it, all right, if you equate them, you get half AB equals to half CD AB equals to CD. Not very helpful. Notice that what you want with the EF is actually gone already. So now we need to employ a new trick here. So a new trick here is this. So how do you get one EF? So by logic, half a EF plus half a EF gives you one EF. So what I can say is half EF is 1/4 of AB. From here, half of EF is 1/4 of CD. So if I add half an EF to half an EF, I get one whole EF. So half EF plus half EF equals to 1/4 AB plus 1/4 CD. So EF is equals to 1/4 of AB plus CD. And this is it for try 3.